Okay, hey, I'm gonna restart example 3 here for you. And so, oops. Okay, and so we're gonna use the difference quotient to find the slope of the curve when x is equal to 9. I think this time I'll use the h. So the limit, oh, there we go, as h approaches zero of f, and we're trying to find it when x is 9. So this will be 9 plus h minus f of 9, all divided by h. There you go. Okay, so then, so this will be the limit as h approaches 0 of the square root of 9 plus h minus 3, square root of 9, divided by h. Cool. And then we're going to do our little conjugate trick that we've done so many times. So we've got the square root of 9 plus h plus 3, top and bottom. Try not to lose anything this time. Square root of 9 plus h plus 3. Okay, so that then gets us to the limit as h approaches 0 of numerator will be 9 plus h minus 9. I'll go ahead and write that. So 9 plus h minus 9. And the bottom will be h times the square root of 9 plus h plus 3. Awesome. And so from there, as we've seen numerous times, we have the 9's canceling, and then after that, this h would become a 1, and then I can substitute in. And so if I substitute a 0 in, I have 1 over the square root of 9, which is 3, plus 3, 1/6. All right, and so then the equation of the for the linear approximation of f near x equals 9 is going to be the equation of the tangent line when x equals 9. All right, so when x equals 9, y is equal to 3. So I'll have y minus 3 equals 1/6 of x minus 9. And it says use that line without a calculator to give an estimate of the curve, the square root curve, using this line that we just created. Okay, so let's do that. So the y will equal, at that moment, 1/6, and we're substituting 9.1 in. So 9 minus, 9.1, sorry. There we go. Back to the pen. All right, so sorry, 9.1 minus 9, and then the 3 that I haven't added, plus 3. Okay, and so this is going to be 1/6 of 1/10 plus 3. So it's going to be 3 and 1/60th. Okay, and I don't know what that is as a decimal, and we kind of need to know that a little bit. Well, we could use a calculator in a second, but now it wants us to graph those two. All right, so if I'm graphing the square root of x, well then when x is 1, y is 1. When x is 4, y is 2. I'm just taking the square root. When x is 9, y is 3. When x is 16, y is 4. Nice graph. And so that looks a little something like this. Hey, that's pretty good. And then the tangent line we used it at 9, so that'd be right here. And because of the concavity, the actual all right. So the actual function values are below that purple line, except at that one moment, which I can make larger there. So we did what we were told to do there. And so then the question is, and this is the kind of thing they ask you all the time, explain whether the answer to C is an overestimate or an underestimate for the actual value of the square root of 9.1. Justify your answer by referencing to the behavior of the graph. Yes. Okay. So here's the thing. So you could say, I think I'll type this. Boop, boop. All right. All right. Since f of x is concave down for all values of x, any tangent line approximation will be an overestimate. All right, that's perfect. A perfect explanation, because as soon as you start talking about the concavity and then the tangent line and all of that stuff, you're talking calculus, and I think that would work very nicely for why it is. And then it says find the actual value of the square root of 9.1, just to see. And so, but I'm going to do a little bit more than that, because I'm a little unsure as to. Get my calculator back here. Hopefully it's still there. Yeah, there it is. All right. Still tied to that. All right. So you out of here. You out of here. Calculator back, but not full screen. And here we are. Okay. All right. So move that over. Okay, so here we go. So getting out of here, and then I just need to know the square root of 9.1. But I'm a little bit more interested in our approximation too. So square root of 9.1 is this. Our approximation was 3 and 1/60th, right? 3 and 1/60th. And we said up here that the tangent line approximation should be larger. So let's see if that held true. Oh my gosh. Yeah, it did. Just by a tiny amount. So that's kind of the point here. The point is your tangent line approximation should be close, but it's going to be more because of the concavity. All right. So, all right. There we go. All right. So what can we say? The true value. I'll just write that. All right, true value of square root of 9.1. Look, we definitely have a repeating decimal on this one, but not on this. That's irrational. So I would say approximately 3.0166, and that was the same as our approximation until we got to that fifth decimal place, 2. Okay, which is less than our approximation of 3.01 and then the 6 repeating forever, right? That's going to be greater. All right. And then it says, okay, how about would a linear approximation for the formula, approximation formula be accurate to you do the square root of 25? Well, why or why not? Well, I mean, if we actually did it, you know, the square root of 25 is 5, right? So, but if I used my approximation right here and tried to do 25 instead, watch what happens. So I've got 1/6, and then instead of 9.1, 25 minus 9. So I'm still traveling along that line. Now, you know the answer is 5, right? Oh, wow. That's not as close. Like, these two were crazy close to each other. I mean, it took us several decimal places to find the difference. But on this one, I mean, we're different right away. And by a significant amount. compared to how large the actual answer is. And the reason would be then they grow apart, right? So the tangent line and the function value are going to grow apart because this is of course linear and this is concave down, and so therefore its slope values are going to decrease, whereas its slope values are going to stay the same. All right, so I think the reason you should say something along the lines of, oops, escape type. Okay, all right, so no, and the reason is the line and f of x begin to move apart from each other. So what we're wanting then is we're wanting to stay close by, and what Gene says on this is we want to stay in a close neighborhood. So if you're in the neighborhood of where the point is, the line is tangent to the function, then that's a good thing. But as you move further away, I mean, 25 is going completely off even what we graphed here, right? So 25 is off of that, and even from my very very rough sketch, you can tell that there would be a big difference between them. Okay. All right. So that is it for example 4.